Hi, in today's video, we are going to be covering back pressure regulators and pressure reducing regulators, their applications, how they operate, and how to maintain them. If you've enjoyed this content and you want in-person training, visit the training page on our website. There you can schedule us to come out to your place, or you can come here to one of our Kimray stores and we can do the training in person. So there are two main types of pressure regulators. So we have back pressure regulators and pressure reducing regulators, or we like to abbreviate that to BP for back pressure and PR for pressure reducing. Those are the two main categories, and then there's subcategories or submodels underneath each one of those. When we talk about pressure regulators, their main operating pressure ranges are from 10 up to 300 pounds. There are some subvariants of each one of those that go below 10 psi, and we'll talk about those. But in general, 10 to 300 psi. So when you're looking at an application for a regulator, nothing above 300. That's when you get into different product high pressure control valves and high pressure control valve packages to regulate over 300 psi. So everything we're talking about in this video is going to be sub 300 psi. So the first regulator I really want to dive into is the back pressure regulator. All of these regulators are available from 1 inch up to 6 inches. So they can accommodate a wide variety of flow rates and different applications. The back pressure regulator regulates upstream pressure, so everything that comes before the valve. Normally that's some type of separator, so it could be a heater treater, could be a bulk separator, could be horizontal or vertical separator, 2-phase, 3-phase. There's a lot of different kinds of separators, but this regulator is what controls the pressure for that piece of equipment. Without this regulator, pressure would just be flowing through the vessel. You're not controlling that pressure. I always have related it back to a water gun. Like if you put water in a water gun and then just immediately squeeze the trigger, nothing happens. You have to pressurize the vessel that's on that water gun, so that way when you squeeze the trigger or a valve opens, that pressure in the vessel forces that liquid out. And so we want to control the pressure on these different pieces of equipment so we can move liquid from process to process, from a separator to storage, or from the first stage of separation to the second stage of separation. We need to be able to move those liquids. And so having back pressure on these vessels allows us to do that. So as we dive into this schematic of a back pressure valve, the red that you're seeing is the upstream pressure. So that's the control point of this regulator. Upstream pressure is communicated through external tubing, and so that's on the gauge side. A good way to be able to tell the difference between a back pressure and a PR real quick. The gauge is going to be on the control side of the regulator. So if you're controlling upstream pressure, the gauge will be on the upstream side. If you're controlling downstream pressure in a PR, the gauge will be on the downstream side. Upstream pressure is communicated through the external tubing. It goes through a filter on the outside of the regulator. This is to catch any large debris that might be in the upstream pressure and flow. So it's going to take out the larger pieces of trash and catch that before it gets to the pilot of the regulator. So that pressure continues on and makes its way to underneath the diaphragm and diaphragm plates. Now on top of that diaphragm is a spring. This is the spring that controls our set point. The more tension you have on that spring, the greater the set point will be. So as you increase tension on the spring, the regulator will hold more back pressure. If the upstream pressure overcomes the tension that's on the spring, so that means that we are above our set point and we want that regulator to relieve the pressure, That moves the assembly up, which seats the larger ball of the pilot plug and eventually unseats the smaller ball of the pilot plug, venting out the pneumatic signal that's holding the valve in the closed position. So that signal, when it's vented, the upstream pressure pushing up on the valve seat will unseat the valve. The regulator will then open and start relieving that pressure. This action happens over and over and over again as it's regulating the pressure. As soon as the pressure exceeds your set point, the valve will vent to open the valve. As soon as you get back below your set point, that spring forces the pilot plug assembly into the other position, which refills that cavity, closing the valve. One key thing to point out is that the area of the diaphragm is twice that of the valve seat. So the same amount of pressure that's in the valve body is also on that diaphragm, keeping the valve closed. So if you had 100 pounds upstream on the valve body, you would have 100 pounds on that diaphragm, keeping the regulator closed. Because of the difference in surface area, it's twice the surface area of the valve seat. That same pressure is able to create twice as much force on the larger diaphragm to keep the valve. I keep saying valve. I use valve interchangeably with regulator. You guys know I'm talking about regulators, so if I say valve, just know I mean regulator. Some of the different models within back pressure regulators, we have the back pressure to vacuum. So that would be used in applications where you're holding back pressure still, but on the downstream side of the regulator, there is a vacuum. So most commonly compressors or like VRUs. So you're holding some back pressure, but then downstream of that, there's a compressor pulling a vacuum. You don't want to try to use a normal back pressure regulator in these applications because those are designed to have some positive pressure downstream on the regulator. They won't operate correctly unless you use a specific back pressure to vacuum regulator. So be aware of that. We also have low pressure back pressure regulators. So those can control anywhere from a half an ounce all the way up to 20 psi. So you would use those in applications where you're below 10 psi and you're wanting to control that. There's 3 different spring ranges. We have half an ounce up to 2.5 pounds. We have a 1 pound to 5 pound, and then we have a 1 pound all the way up to 20 pound spring. So depending on your specific application, you'll just choose the correct spring for that. We also have a non-vent version of the back pressure regulator. When I was talking through the operation earlier in this video, I talked about the pressure that holds the regulator in the closed position. When it has to open, it has to vent that pressure. That pressure in our back pressure regulator goes to atmosphere. The non-vent version captures that vented gas in tubing and directs it downstream of the valve. So there's more external tubing on that back pressure regulator, but it just prevents any fugitive emissions. It just captures that gas and redirects it downstream. So everything's contained in the flow stream. We also have a back pressure regulator that has outside supply. So in applications where you have dirty supply gas or you're concerned about emissions or reliability, what you can do is bring in your own supply of compressed air or even nitrogen, and that will prevent this valve from emitting any gases. Because instead of venting the natural gas that it pulls from the upstream side of the valve, you're just venting air or you're venting nitrogen. But it's important to know that you need at least 60% of upstream pressure for your supply. So in the case where you had 100 pounds upstream, you would have to give the valve at least 60 pounds of supply for it to operate. And the reason for that is because of that ratio we talked about between the area of the valve or the regulator seat and then the diaphragm in the regulator. So if you had 100 pounds upstream, but you only supplied it with 40 pounds of supply, the upstream pressure is going to create enough force on that valve seat to force it open. If you're only pushing down with 40 pounds, but you have 100 pounds pushing up, even though you're double the area on the diaphragm, that's not going to create enough force to have the regulator operate correctly. So it's important to always get at least 60% of the upstream pressure. I normally tell people just match upstream pressure. Whatever your set point is, just try to match that just to be safe, but at least 60% of upstream pressure. Back pressure regulators can be converted from one series to another. So if you have existing regulators in the field that are operating, but you're wanting to change over to non-vent or outside supply, we sell conversion kits for those that makes it easy to retrofit those without having to change the entire valve out. There are lots of material options for regulators, lots of different elastomer types you can put on there. So if you're in sour gas service, we have elastomers for that. You can order these with stainless steel internals. That way they stand up to those, wet gas, sour gas applications and last longer. There are 2 trim options or port sizes for each size regulator. So we have the full port version, which just matches the inlet size. So if you had a 4-inch regulator, you'd have a 4-inch seat or port inside of the regulator. Then we have a reduced port for each size as well. So full port, reduced port, and that just cuts the valve seat size in half. So if you had a 6-inch regulator, but you had a reduced port, it would be a 3-inch port inside of that 6-inch regulator. Or if you had a 2-inch regulator, it goes down to a 1-inch port size. And that just gives you some flexibility on not having to change out an entire valve. You can easily change out the trim size with the valve body in place. You don't have to change out the entire valve. So retrofitting, especially in applications where production has decreased, going from a full port regulator to a reduced port regulator is an easy thing to do. Another model of back pressure regulator that we have is the spring-loaded back pressure regulator. It operates a little bit differently than the back pressure regulator does. The spring-loaded back pressure regulator is a little more simple. The upstream pressure is communicated to underneath a diaphragm and diaphragm plate, which then operates against a spring. As the upstream pressure increases, it will overcome the spring tension, and that just moves the entire stem assembly up, which unseats the valve and allows that pressure to flow through. On the full port models of the spring-loaded back pressure regulator, that upstream pressure is communicated underneath the spring through tubing on the outside of the regulator. The reduced port version of the spring-loaded back pressure regulator, that pressure is communicated internally through a hollow stem. So if you ever see a spring-loaded back pressure valve with no tubing on the outside, that's an indication that it is a reduced port regulator. These regulators can be used in both liquid and gas applications. That's one of their advantages. If you are controlling liquid back pressure, you can use the spring-loaded back pressure valve, but also, or alternatively, you can use the back pressure regulator with outside supply. So because we're not pulling supply from the upstream side of the valve, you're bringing in your own dry supply. You can use those in liquid applications as well. So regulators in general, you don't want to use in liquid applications. But more specifically, if you do have liquid applications where you need to control back pressure, we have the spring-loaded back pressure valve, and then we also have the back pressure regulator with outside supply. So both of those can be used in liquid applications. The spring ranges for the spring-loaded back pressure regulators are anywhere from 1 to 125 psi. There's multiple spring options. We don't have one regulator that can do from 1 to 125. There's a lot of different spring options. Usually they vary about 30 to 40 psi. So we have like a 1 to 20 pound spring. We have for example, a 20 to 40, and so on. And so you make sure you're selecting the correct spring for the pressure that you want to control. All right, so that was back pressure regulators. Now we're going to shift over to pressure reducing regulators, or PR regulators. Now the applications where you use PRs are the exact opposite of back pressure regulators. So back pressure regulators controlling upstream pressure. PR regulators were controlling downstream pressure, or what comes after the valve. Most commonly, those applications are suction control valves on compressors, or other applications where you want to reduce that pressure. You're controlling what's coming out of the regulator. They work really similar to the back pressure regulators. The gauge is on the downstream side, so we can identify this as a pressure reducing regulator. So we're still pulling supply from the upstream side of the regulator, and that is going directly to the diaphragm, or the motor valve diaphragm. That's the portion that keeps the regulator in the closed position. You can see the red pressure just goes directly into that portion underneath the pilot plug. The pilot plug is inverted from the back pressure regulator, so the larger ball of the pilot plug is on the bottom, and then the smaller ball is on the top. The downstream pressure is now the pressure that's communicated to underneath the spring. As that pressure overcomes the spring tension, which is our set point, that is going to move the pilot plug. The upper seat will lift up, and that will allow the yellow diaphragm pressure to vent, and that just ensures that the upstream pressure is pushing that valve stem assembly down and seating the valve and closing it off. So we are above our set point downstream. So we want the regulator to close and make sure that it's not allowing more pressure to flow through the valve to increase that set point. Now, if downstream pressure gets below our set point, or the spring tension overcomes that pressure, we seat the upper pilot plug, which is the path to vent or path to atmosphere, and then it'll continue to push that down, unseating the lower ball of the pilot plug. And then the pressure above and below the motor valve diaphragm equalizes. So that upstream pressure will go from what we're showing as the red pressure to the yellow pressure. And so the pressure equalizes on both sides of that diaphragm, and that allows the upstream pressure that's pushing up on the valve seat to open the valve and flow downstream. Another variant or another model of a pressure reducing valve that we offer is the pressure reducing balanced valve. You would use this valve in applications for suction control on a compressor. Our standard pressure reducing valve has a set point drift ratio of 8:1. Whenever the upstream pressure changes by 8 psi, the set point drifts by 1 psi. So if you have wild swings in upstream pressure in a suction control application, your set point will drift up and down with that change in upstream pressure, which causes your compressor to have to work harder, and that variance in set point change could actually shut your compressor down if it changes enough. So to prevent that from happening, we have a pressure reducing balanced valve, which has a 100:1 ratio. And so the upstream pressure would have to change by 100 psi for there to be a 1 psi change in your set point. So a much larger ratio, which prevents your set point from drifting, which just increases efficiency with your compressor and make sure that it stays running. We have non-vent options for the pressure reducing regulator as well. So again, we're just capturing that gas that would have been vented to atmosphere. We're capturing that and putting it downstream in the valve. We also have outside supply options available. And so if you are, again, wanting to use nitrogen or compressed air to become emissions free or to get away from dirty supply gas to increase reliability, that is another option with the PR valves. Same thing applies for the PR valves as we talked about with the back pressure valves, with using at least 60% of upstream pressure to operate the regulator. And that's all for the same reasons. The low pressure reducing regulators, we have 3 different spring ranges, go all the way from half an ounce all the way up to 20 psi. So if you have an application where you're wanting to reduce the pressure down to ounces or below 10 psi, that is the recommended regulator for that application. With pressure reducing regulators, as we talked about with the back pressure regulators, material, trim sizes, all of that still applies to the pressure reducing regulators, just like it does with the back pressure regulators. Okay, so we've talked about back pressure regulators and pressure reducing regulators. Now I'm going to talk through some maintenance and troubleshooting ideas. These generally apply to both back pressure and PR regulators. Some of the symptoms of an oversized regulator are that the regulator does not fully actuate, or it seems that it's venting a lot. And so, you're listening out for the hiss of the vent, but it's happening really often. And that's because when the regulator opens, because it is oversized, it allows too much gas through. So it just barely opens and immediately has to close. And then it opens and closes, closes, instead of it opening and allowing pressure to start flowing through and then closing, and more of a throttling action, which is what you want in a regulator. It's open, close, open, close, open, close, because it is oversized. So something to look out for. If you're on the other end and your valve or regulator is undersized, it's just going to be open all the time. And it might even be so undersized that it becomes a restriction, and your set point, specifically in back pressure, your set point would continue to rise and rise and rise, and it's just not able to evacuate enough volume of gas where that pressure starts to increase. So a couple things to look out for. When we ship you a brand new valve, or you're unboxing a new valve to install it, after installation, make sure you remove the plug from the vent port on the oil bowl, whether that's a back pressure regulator or a PR regulator. The oil bowl holds oil to lubricate an O-ring that the valve stem travels through. But during transit, we have to plug that hole so the oil doesn't spill out all over the box and soak the box. But if you do not remove that plug, it more or less vapor locks and doesn't allow the regulator to move fully or freely. And so removing that plug, just make sure that atmospheric pressure can get into the parts of the regulator it needs to be able to operate correctly. We have a tag that's on every single regulator that says, before operation, remove this plug, and it shows a little picture of it. But if you're like me, most of the time when I get something new, I'm ripping off the tags and not paying attention to the instructions. But that's a common question that we get, is why isn't my brand new regulator not operating as it should? So make sure you take that out after you install it and before you try to operate the valve. I mentioned it a few times before, but wet and dirty gas causes a lot of issues for our regulators. The pilot plug seating surfaces are really small, so if you get any kind of liquids in there or trash, it can cause issues with the operation of the regulator. We have that filter that takes out, the big stuff. There's several screens in there that can filter out some of the big debris. But if you have liquids in your gas, that's still going to get through. So if your regulator is venting continuously or not holding its set point well, it's probably an indication that the pilot plug has some debris or trash or wet gas in it. Something you can do to check that, or a quick fix, is if you adjust your set point quickly. So if you back out the adjusting screw really quickly, what that causes is the valve to vent rapidly, because it's saying, oh, now my set point is much lower. I've got to get rid of all this back pressure I'm holding. So if the valve vents hard, sometimes you can blow out that debris or that wet gas. Now, if it's a problem you're continuously running into, there's other solutions to look at. But quick fix, or to check if there is debris, is to run the adjusting screw in and out really quickly. And that will get that regulator to change position and hopefully blow out the debris that could be stuck in it. If that's not working, or you're having to do that a lot, and it comes time to repair the valve or do any other maintenance in it, you can repair these regulators in line. You don't have to remove the valve body. You can get to all the internals when the valve body is in line. We now have master repair kits because we have so many sub-variants or different models of back pressure regulators and PR regulators. The 2-inch regulator repair kit will repair the non-vent, the outside supply. It'll repair all those 2-inch regulators. So it's important to keep in mind that if you're using a master kit, you will have extra parts left over. That is intentional. You didn't forget to put something in the regulator. Those pieces are just meant for a different model of that same size regulator. And so that's listed out pretty well on the repair sheets that come in the repair kits. So just pay attention to what you take out of the regulator, and then make sure you put that same amount of O-rings and diaphragms and gaskets back into the regulator, and to make sure that you've repaired it correctly. Thanks for watching this video. If you have questions, you can contact Kimray support or comment below.